You are standing in line at an airport. You check the boarding time. You glance at the people ahead of you. You mentally calculate how long this will take. No one explains the rules out loud. No one coordinates the order. Yet the line mostly works. People move forward. The plane boards, and a complex system quietly does its job. This is a queue. A simple idea, but also one of the most powerful organizing systems in modern life. Queues decide who gets served, when, and in what order. They decide whose time is protected and whose time is spent waiting. In this episode, we will look at how queues actually work, not just as lines of people, but as invisible structures inside software, services, and institutions. We will see how they enforce priorities, how they translate power and money into time, and how they shape the future without saying a word. A queue is, at its core, a waiting list. Items arrive, they are held, and then they are processed. In the physical world, the items are people. In digital systems, the items might be messages, tasks, or requests. The basic rule most people know is first come, first served. You arrive, you join the back. You move forward as others are processed. This rule feels fair. It matches our sense of time as something that moves in one direction. But the reality is more complicated. Most real queues do not follow a pure first come, first served rule. They run on more complex systems of priority, value, and risk. And those systems are often invisible. Consider a typical day. You wait in line for coffee. You wait for a reply from customer support. You wait for a file to download. You wait for a ride from a car-hailing app. All of these are queues, but they operate on very different rules. In a coffee shop, the queue is visible. You can see your position. You can see the barista. You can estimate the time. In a customer support system, the queue is mostly hidden. You submit a ticket. You receive a message. Your request is important to us. We will respond as soon as possible. You are in a queue, but you do not know how many people are ahead of you. You do not know who gets prioritized. In a digital system, your request might be tagged, perhaps by urgency, by subscription level, by region, or by predicted complexity. The visible story is, we answer everyone. The actual system might be, we answer high-value customers first. We delay low-value ones. We drop some requests entirely if load is too high. The queue is doing more than organizing time. It is sorting people according to the goals of the organization. To understand this, it helps to look at what queues are designed to optimize. From a systems point of view, a queue is not about fairness. It is about managing limited capacity. There are three main variables. Arrival, how quickly new requests come in. Service, how quickly each request can be handled. Capacity, how many requests can be processed at the same time. If arrivals exceed capacity for long enough, the queue grows. Waiting times increase. People get frustrated. Some give up. So designers of systems have to choose. They can increase capacity, they can slow arrivals, or they can change the rules of the queue. Often, changing the rules is the cheapest option. This is where priority comes in. In an emergency room, patients are not seen in the order they arrive. They are triaged. Someone with chest pain may jump ahead of someone with a broken arm. The system is not optimizing for fairness. It is optimizing for survival, for risk reduction. In an airport boarding process, the priorities are different. Airlines board people with higher status first, people who paid more for tickets, families, then everyone else. The system is not optimizing for medical urgency. It is optimizing for revenue, loyalty, and speed of turnaround. In a cloud computing system, tasks are also queued. Requests from paying customers may be processed immediately. Requests from free users may be slowed or dropped if the system is overloaded. Again, the queue is not just a line. It is a filter. It turns time into a currency. If we look closely, we can see a few common patterns. One pattern is the visible line, the physical queue. Supermarkets, post offices, security checkpoints. These lines are often designed to reduce conflict. Clear barriers, stanchions, signs, they make the rules legible. Everyone can see who is ahead. Everyone can see who is behind. This visibility is not accidental. It reduces the need for negotiation. It reduces the need for enforcement. The line itself becomes a social technology. Another pattern is the single queue that feeds multiple servers. You may have seen this at banks or airports. One line, several counters. This design is more efficient than separate lines. If one counter is slow, the others keep working. The average waiting time goes down. Many digital systems use this model. A single queue of tasks, multiple worker processes. You never see the line, but the logic is the same. A third pattern is the invisible, prioritized queue. This is common in software platforms. Requests arrive, they are placed into different internal queues. Some are processed quickly, some are delayed, some are retried, some are abandoned. The user sees only a spinner, or a loading bar, or a message that says, "Please wait." The system does not just decide who goes first, it also decides who may never be served at all. Virtual queues are becoming more common. When a concert goes on sale, a website might place you in an online waiting room. Your browser shows a number. You are 54,302 in line. Behind the scenes, the system is controlling arrivals. If too many people hit the purchase page at once, the site might fail. So the virtual queue shapes traffic. It releases people in controlled batches. The goal is not to eliminate waiting. The goal is to avoid collapse. Something similar happens when a game launches. Players try to connect. Servers reach capacity. The system creates a login queue. Players see this as an inconvenience. For the operator, it is a safety valve. The queue protects the system from overload. Digital queues can also be used to shape behavior. Some customer service lines will play a message. Press 1 to receive a callback instead of waiting on hold. You are still in a queue, but the experience has changed. You are now waiting off the line. You might be more patient. You might be less frustrated. This is not just about kindness. It is also about metrics. If people are not actively on the phone, the call center's average hold time looks better. Abandonment rates may decrease. Customer satisfaction scores may improve. The queue stays the same. The perception of the queue changes. Something similar happens with delivery estimates. An app may tell you your food will arrive in 40 minutes. It might arrive in 25. The system has padded the estimate. This gives it room to handle variability, and it improves the chance that you feel pleasantly surprised. The queue is managing your expectations as much as your order. Queues also exist inside organizations. Emails in an inbox are a queue. Tasks in a project management tool are a queue. Decisions waiting for approval on a manager's desk are a queue. In these cases, the rules are often informal. A manager might respond first to whoever writes the most urgent-sounding subject lines, or to whoever is physically closest, or to whoever they like the most. The queue is still there, but it is governed by personal heuristics instead of explicit rules. This has consequences. People learn to game the informal queue. They mark emails as urgent. They escalate directly to higher levels. They copy more people. The internal queue becomes a negotiation. Some organizations respond by formalizing it. Ticketing systems, service-level agreements, response time targets. These convert vague waiting into explicit metrics. Time becomes measurable. And once it is measurable, it can be optimized. Every queue has trade-offs. A strict first-come, first-served system feels fair, but it can be inefficient. A patient with a life-threatening condition may wait behind someone with a minor issue. A priority-based system is more efficient for certain goals, but it may feel unfair. People with more money or status may consistently wait less. Others may wait more. Some systems try to balance these forces. They might reserve a portion of capacity for urgent cases. They might throttle low-priority requests rather than blocking them entirely. But the underlying logic remains. A queue is always a reflection of what the system values. If a company optimizes for paying users, the queue will prioritize them. If a hospital optimizes for survival, the queue will prioritize risk. If a platform optimizes for engagement, the queue will prioritize content that keeps people active. Waiting time becomes a signal. It tells you where you sit in the system's hierarchy of importance. There are also costs that queues tend to ignore. Time spent waiting is not evenly distributed. People with flexible schedules can absorb delays more easily. People paid by the hour lose income when they stand in line. A 1-hour wait does not mean the same thing to everyone. Yet in most systems, time is treated as if it were uniform. Similarly, queues rarely account for uncertainty. Not knowing how long you will wait often feels worse than a known delay. Systems that provide estimates, progress bars, or position numbers are trying to manage that uncertainty. They do not always change the actual waiting time. but they change your relationship to it. As more of life moves into software, queues become more abstract. You may never see the line, but you still feel its effects. Videos buffer, payments penned, documents sync. Each delay is a negotiation between your request and the priorities of a distant system. The future is being shaped in these small negotiations. Who gets fast access to information? Who waits for approvals? Who receives immediate support? Who is quietly deferred? These are not just technical choices. They are structural decisions about whose time is protected. When you step back, queues form a kind of hidden calendar. They schedule who gets to move first, who must pause, who effectively stands still. You don't see them as appointments, but they still allocate your hours, your patience, your attention. Tomorrow's systems will likely add more layers of intelligence to these queues. More prediction, more personalization, more invisible prioritization. But the basic logic will remain. Every queue is a statement of values. Every wait time is an encoded decision. The next time you are told to hold, or to wait, or to stay on the line, you are not just in a delay. You are inside an organizing system that is quietly deciding how much your time is worth. Thank you for watching this episode of Systems of Tomorrow. See you next time.